Today we will be dealing with a new chapter. The chapter's name is Atmospheric Circulation and Weather System. Here we have a clear-cut concept about atmospheric pressure and whatever things we have studied in the past, that's being detailed in this chapter. Okay. So first of all, atmospheric pressure. Let's understand this atmospheric pressure. What's that? Atmospheric pressure is the force exerted on a body in the atmosphere. Okay, this is a simple meaning of this atmospheric pressure. Since pressure we know, force per unit area, that's called pressure in general physics. Okay, similar is the case over here. The weight of a column of air contained in a unit area from the mean sea level to the top of the atmosphere is called atmospheric pressure, which is measured in millibar, and at the sea level the average atmospheric pressure is this much. This is the data, 1013.2 millibar. And as we know that as we move up, the temperature decreases. This is mainly because of the decrease in the atmospheric pressure. What happens then on the surface of Earth? On the surface of Earth, the atmospheric pressure is denser, that's maximum. Okay, and as we move up, the atmospheric pressure decreases, and that causes a decrease in the temperature. Okay, so atmospheric pressure is a pressure exerted on any body in the atmosphere because of the presence of air and wind and any other kind of force that's responsible for the movement of air. Okay, simply we can say that atmospheric pressure is the pressure exerted on a body in the atmosphere. Okay, so what's about the apparatus which is used to measure the atmospheric pressure? There are two kinds of apparatus. One is the mercury barometer and the aneroid barometer. Okay, these are the equipments being used for the measurement of atmospheric pressure, or the air pressure, you can say. The atmosphere is actually air only. Okay, the next topic is vertical variation of pressure. How does the pressure vary vertically? Okay, simply we had said that on the surface of Earth the pressure is extremely high. Okay, as we move up, the pressure decreases, atmospheric pressure decreases with height, and this causes a decrease in the temperature. Okay, so as we move up, the pressure decreases, or the air pressure decreases, or the atmospheric pressure decreases, which causes a decrease in the temperature. One more point has been given over here is that the vertical pressure gradient force is much larger than the horizontal pressure gradient, but it is generally balanced by a nearly equal but opposite gravitational force. Hence we do not experience strong upward winds. Okay, whenever we are just at present whenever we are present on the surface of Earth, we always generally feel that the wind is moving across us, it is passing by us. We are not observing any wind which is just vertically overhead us, and that is just trying to push us downwards. Rather we experience that the wind is trying to push us forward or backward in a horizontal manner, not in a vertical manner. Okay, so this is because the vertical gradient force is much larger than the horizontal pressure gradient. Now we will be discussing about the horizontal distribution of pressure. Okay, we will be discussing with a term called isobar here. In the previous chapter we had dealt with isotherm. That's a place or a zone which is having a common temperature, which are which are present at the same temperature levels. Similar is the case with isobar, those places very which are having a very common kind of air pressure or pressure actually are called the isobars. Horizontal distribution of pressure is studied by drawing isobars at constant levels. Isobars are lines connecting places having equal pressure. Okay, this is something which we have just studied. So this is about the existence of low pressure and high pressure zones on the planet Earth. Okay, so we will be discussing next the world distribution at the sea level pressure. Okay, here we will be dealing with four types of pressure belts actually. First one would be the equatorial low pressure belt. The second one would be the subtropical high pressure belt. Then would be the subpolar low pressure belt, and the fourth one is the polar high pressure belt. Okay, so a simple way to remember this is that equator is just passing through the middle of the earth. So 5 degrees above that and 5 degrees below that we have a pressure belt called equatorial low pressure belt. Okay, and from 5 degree north to 30 degree north and 5 degrees south to 30 degrees south we have subpolar high pressure belt, subtropical high pressure belt. Okay, and from 30 to 60 north and 30 to 60 south we have subpolar low pressure belt. Okay, and above 60 north and 60 south we have polar high pressure belt that comprises of the polar zones. So this is the variation of the different pressure belts on the surface of earth. Okay, so next is forces affecting the velocity and direction of wind. Okay, now we will be dealing with various kinds of factors which are affecting the direction and forces of wind, velocity and direction of wind. Okay, first one is the pressure gradient force. Okay, the difference in the atmospheric pressure produces a force. The rate of change of pressure with respect to distance is the pressure gradient. This pressure gradient is strong where the isobars are close to each other and is weak where the isobars are apart. So atmospheric pressure difference, whether it is high or low, this pressure gradient creates a difference in the velocities of wind at various places. Okay, the pressure gradient is strong where the isobars are close to each other. Isobars are those places which are having a common pressure, which are located at the same pressure level and is weak where the isobars are apart. The frictional force is something which is affecting the speed of the wind. It is greatest at the surface and its influence extends up to an elevation of 1 to 3 km. Over the sea surface, the frictional force is minimum. Because of the presence of the air resistance or the frictional force, the actual speed of the wind gets reduced. Okay, It is actually greatest at the surface, and its influence generally extends up to elevation of 1 to 3 kilometers. Over the sea surface, the frictional is minimal because there is extremely evaporation taking place over the sea level, which constitutes the rising of the water vapors and air onto the level of earth, over the level of earth into the atmosphere. So the frictional force is minimal over the sea. Okay, next one is the Coriolis force, which is mainly because of the rotation of the earth or about its axis, affects the direction of wind also. This force is called Coriolis force after the French physicist. It deflects the wind to the right direction in the northern hemisphere and to the left direction in the southern hemisphere. This is about the Coriolis force. Okay, the deflection is more when the wind velocity is high, directly proportional to the angle of latitude. It is maximum at the poles and absent at the equator. One important thing is that Coriolis force is not existing on the equator. Okay, the reason is that it's because of the rotation of earth around its own axis, and on the equator we know that everything is just 0 0 0. The latitude level is also 0. Okay, and it's quite in the center of the sphere, so we do not experience generally the Coriolis force. Okay, because if any force would have existed, it would have created differences over there too. The Coriolis force acts perpendicular to the pressure gradient force. The pressure gradient force is perpendicular to the isobar. The higher the pressure gradient force, the more is the velocity of the wind and larger the deflection. The Coriolis force is 0 at the equator and the wind blows perpendicular to the isobars. Low pressure gets filled instead of getting intensified. That's why the tropical cyclones are not formed near the equator, because of the absence of the Coriolis force. Okay. So tropical cyclones are important phenomena which are occurring mainly because of the Coriolis force, the force created due to the rotation of the earth around its own axis. But near the equator there doesn't exist any kind of Coriolis force. That's why there doesn't exist any kind of tropical cyclone. The pressure and the wind. The